Read the material on the screen. The factor we are investigating is how catalysts affect the rate of the reaction. The reaction we will be observing today is the decomposition of aqueous hydrogen peroxide into hydrogen gas and oxygen gas.
The reaction is H2O2 aqueous, yields H2 gas and O2 gas. In our experiment, we will put 4 potential catalysts into the mixture of hydrogen peroxide and soap water and attempt to observe the reaction. We will also use a burning splint to test whether there is oxygen gas present from the decomposition. The catalyst should decrease the activation energy of the reaction. Since hydrogen peroxide decomposes on its own, the catalyst should cause the reaction to happen more quickly and be more pronounced. Catalyst is a substance that increases the rate of reaction without being chemically altered due to lowering activation energy needed to initiate a reaction. Thus, in a potential energy reaction graph, the activated complex, potential energy of the activated complex, and activation energy of the forward and reverse reaction lowers, but the potential energy of products, reactant, and heat of reaction delta H remains unchanged.
First, we will pour a small amount of hydrogen peroxide into each test tube using a dropper. Then, we will add about 20 drops of soap water solution to each test tube using a different dropper. After that, we can begin adding the potential catalyst to the test tubes. Using 4 separate droppers, we'll add roughly equivalent amounts of iron 3 chloride, iron 3 nitrate, sodium chloride, and sodium nitrate solutions to their respective test tubes as labeled. After a bit of time has passed, we can see that a strong reaction has started to occur in the test tube where we added iron 3 chloride to the hydrogen peroxide solution. Additionally, a weaker reaction has started to occur in the test tube where we added iron 3 nitrate as well. Meanwhile, there is no visible reaction in the test tubes where sodium chloride and sodium nitrate were added. These reactions show how the hydrogen peroxide is decomposing into hydrogen and oxygen gas at a faster rate due to the presence of a catalyst. To check that the decomposition reaction has happened properly, we can dip an embering wood splint into the bubbles that formed during the reactions. These bubbles should be filled with trapped oxygen gas, so if a reaction has occurred properly, the wood splint should light back on fire. Upon being dipped into the bubbles, the embering wood splint lit on fire almost immediately, proving that a decomposition reaction did occur.
As you can see, the first potential catalyst, sodium chloride, caused no noticeable reaction in the test tube. For the second potential catalyst, iron 3 nitrate, the mixture turned a dark color and bubbles started rising on top of the mixture. However, it wasn't until a couple of minutes later that the bubbles rose out of the test tube. The third potential catalyst, sodium nitrate, also had no reaction. Finally, the fourth potential catalyst, iron 3 chloride, had the biggest reaction. When we added the catalyst, the mixture immediately turned a darker color and bubbles formed and rose out of the test tube very quickly. When we tested the burning splints, both catalysts that caused bubbles to form made the matches light up, although the splint put in iron 3 nitrate was quickly extinguished by the liquid. In conclusion, the catalyst that caused a larger reaction with the hydrogen peroxide was an iron 3 ion. This catalyst lowers the activation energy needed for the reaction, causing it to happen faster because the energy already present in the reactants becomes sufficient for the reaction to occur.